Hello and welcome to New Wave, your go-to resource about climate investing in Europe. Today I sit down with Khullar, co-founder and CEO of Aris Machina, alongside Peter Carlson. They are fresh out of stealth with a massive 9 million pre-seed round and an ambition that is hard to overstate. They want to build the Agentic OS for complex manufacturing, starting with batteries. In this conversation, Sid shares the founding story for Aris Machina and the moment at Northvolt that made him realize this OS needed to exist. We talk about how he raised one of Europe's largest pre-seed round after hearing 300 no's from investors. We also talk about modern factories, LLMs, agents, and the future of manufacturing. As always, before we start, please don't forget to like, comment, and subscribe if you're on YouTube, or to give us a follow and a 5-star review on Apple Podcast and Spotify. There's also a newsletter that I send weekly about all of the news in climate tech. Feel free to subscribe to this one. All right, Sid, thank you so much for taking the time to chat today. You recently came out of stealth with Aris Machina or Machina?
We go with Machina, Aris Machina, and the word or the name of the company has origins in Greek and Latin. Aris comes from the word aristo, which is excellence, and Machina is Latin, I think, is the origin is machines. So the name of the company essentially translates to the excellence of machines.
I love that. Such a great name. But look, you've recently came out of stealth, massive pre-seed round, about 9 million euros. I'd love for you to touch a little bit on what you're building and what you're trying to solve.
In short, we are building an agentic operating system for complex manufacturing. And, if you look back at the history of creation, every leap in capability that we have created or built or invented to manufacture has brought a subsequent growth in complexity. Whether it's, the first tools we brought to the Industrial Revolution or were the shovels for Industrial Revolution, whether we went from, prescriptive manufacturing on a Ford assembly line to predictive manufacturing. We've gone from a few parameters to tens of parameters to hundreds to thousands. And now we are at tens of thousands, right? And the modern manufacturing it operates at scales that of precision that have been unimaginable. And it's and even a generation ago. And this has brought a lot of complexity. And the data has the promise of collecting data has been met, but promise of utilizing data, it tells us the what happened. It doesn't tell us why something happened. And it's largely underutilized and undertapped. And I experienced this firsthand when I was leading software and AI at Northvolt. And we built a few very interesting tools using generative AI, early days 2023. And I think now we are almost at the cusp where the conditions for building what I like to call industrial superintelligence are very much prime to utilize. And what I mean by that is AI is just getting to a point where we can compress a lot of unstructured, disconnected information into contextualized reasoning plane, right? And if you think about it, and this is not about collecting data in data lakes and so on. This is really truly contextualizing unconnected, disconnected knowledge. And it's more about utilizing knowledge. It's not necessarily so much about utilizing just the data. And that's the plane that we are building on top of. So the knowledge is about this industrial ontology, which is what I like to call the base of the operating system. And then comes the agentic workflows, which are almost an operational twin of your factory or your R&D team or your business. Palantir has actually done an incredible job at executing this operational workflow twin with both combination of Foundry and Gotham and all the other products they have. And then on top, I firmly believe that chatbots are not going to be the win it all for industrial, at least. So we are very carefully thinking about what does a scientific user interface look like, or what does an operational user interface look like? What are and I spent a bunch of time in HCI at Microsoft Research, and I worked with some of the best people there. And I've always had a soft corner for good user interfaces. And this includes ways of interaction, not just design of a UI, but it's about how you interact with voice, with touch, with vision, with your visual system, how you think about it, what is your behavioral pattern, what is your life outside a factory, how do you blend in the ways of communication you have naturally outside the factory with ways of communication you have at work. And these are questions that I'm very passionate about.
And I think there's a lot to unpack within that story. But look, I mean, one of the things I want to talk about, and I think that is such a win for Europe, and I'm actually very proud of your investors for that. You talked about Northvolt very briefly. I think in one article recently, you describe it as hard-earned scar from
Yes.
past industrial battles. I'm
Yes.
curious, like, how does that experience shapes you? Because obviously, it is a difficult experience to go through. How does that make you a better founder? Because I think it ultimately makes you a better founder.
Thanks for saying that. And I honestly believe everyone I spoke with when I was starting this company, and including Peter himself, whoever both of us spoke with, we were quite, of course, we were sad about how Northvolt's chapter folded. But I'm glad, it's in good hands now with Lighten. But I think it was a very fortunate experience to be there when we went from the largest scale up in Europe to no one ready to fund a bridge of 6 months, and letting it go to both first Chapter 11 and then Swedish bankruptcy. It was a huge learning lesson on what happens when an operation of that size folds, and why certain things are the way they are, and what you can do to avoid that. I mean, these were really lessons that you get with a front seat that you wouldn't get anywhere else. And I used to tell my team, no one else in the world is solving the problems right now that we are trying to solve in this context with this, you know, level of urgency. So I think all this muscle that we are gaining, everything else is going to seem boring after this. And this was, I think, one of the key things about why I wanted to start this company, because I just felt like I won't be able to find a problem that is more exciting than what I just went through. And I'll just be bored and depressed if I don't start this company.
Yeah, you didn't have a choice just to start again. But look, you've spent actually, I think that makes it very interesting about your profile is that you came out of Northvolt. You obviously start this Agentic OS manufacturing company in battery as the first industry that you're tackling. I guess was there a moment when you bought Northvolt and then you realize, okay, that actually this needs to exist. Like we need to build it, and
Yes,
I need to be the one that builds it.
yes. There was a moment. In fact, there was a couple of weeks that really convinced me that a product like this needs to exist. And it was actually a customer problem that came down to our laps. And it was a massive yield loss in a part of the factory that was really, I think, the 95th step in the manufacturing line. So you spend all this time and you get to a point where you measure a certain parameter, and you have everything else, like 12,000 parameters before that point, that could be a cause for this problem. So now yeah, good luck, right? You cross your fingers, and your customer is yelling at you and saying, "Why don't you know?" And you have some of the best people in the world trying to solve the problem. And we had built a tool that we felt was still falling short. And it was a pretty good tool. Like, the engineers went and did the root cause analysis, and they found in a couple of weeks, and it was still falling short. And I almost was living in two worlds. And this expert who's now at Agratas, he leads the Tata's manufacturing project in London, in Oxford. His name is Everett Wiggins, and I hope he doesn't mind me mentioning. He kept telling me from the beginning that, this is a problem that we may not find in the data. It is somewhere, something happened that we forgot to log. And it is likely this particular parameter in this part of the factory, which was like step 2 in the factory. And I was like, are you sure about this? And, so he was like, no, we have to rule out all these other things first before we go there, because we have to be systematic. And I just kept sitting there and wondering, like, what if someone has this knowledge, how could you actually accelerate while everything else also gets done? And this was the moment for me where I felt like, and it eventually did turn out to be this thing where we used AI to then rule out 30 possibilities. There's a concept called the Ishikawa root cause analysis diagram, which is kind of cause and effect analysis, that you take out each bone in this fishbone diagram and you eliminate it, and then you're left with a few root causes, and then you go dig deep. So we used AI to go search a bunch of documents that we felt might have the root cause. And it ended up being like a small construction log entry in an Excel file that talked about opening up a hole in a wall, which caused the moisture conditions to change in the factory. And incidentally, there was a machine parameter that was out of spec. Both things happened together by accident, but you almost can never find these things systematically, at least not from my experience. And I'm sure people will argue, no, if you build your factory correctly and you build your data pipelines correctly, this is easily findable. So maybe it is. But that was my realization moment, that if we are struggling with this and the losses because of such things run in millions, there is a huge opportunity out there where the number of parameters are now way past the cognitive bandwidth of even a very smart large engineering team to manage. So we do need this inorganic intelligence to compress information and help people who have trained all their lives to do complex things be and live up to their potential.
There is one level of complexity that I'm trying to understand how you solve for, which is, uh, as you said, you have disorganized data or data that sits everywhere and anywhere in the factory, from Excel files to PDF docs to whatever that is. How do you process all of that? Because I think what you're trying to build is not to rebuild the data pipelines themselves, but rather build the layer that aggregates everything. Is that correct?
It's more the layer that connects everything, in a contextualized manner. So think of it this way. An ontology is a graphical representation of assets, actions, and outcomes, right? And all three of these components of an ontology can have databases behind them, can have programs or code behind them on how to process this. So it's more like a massive multi-node pointer layer, which has a way to interact with a reasoning or an intelligence model, right? So you can essentially use this as more a focusing lens on where to go look when a certain problem happens. So you can be more loose with how you search and how you connect data, right? You don't have to spend all the time in arranging and setting up data in a way that traditional methods need to be bounded by. So I think it's more about using AI to go from unstructured data to a graph, and doing it, because this is one of the key challenges that most manufacturing software companies have, or most manufacturing companies have, is how do I utilize my data? What is all the data I collect? And another moment in time was before we got to this point, that example that I described you. Peter actually came to me in 2023 when we were at the factory and said, I have all this data. Can I just understand how it actually connects and is useful? Because I'm paying $9 million every year to Amazon to store this data. How do we actually use it? And he literally locked me in a room with four other engineers, to my consent, obviously, without any chairs. with four walls, big four walls. It was basically four containers attached together, and we printed out every parameter and we put it on the wall just to understand the scale of data we were collecting. And that was another moment. Like, there is no way we can ever try to do this in a human manner. So I think that's one of the key innovations, is how do you quickly go from unstructured data to a knowledge graph, which becomes a guardrail for agents to not hallucinate. The other point, and I'll give the mic back to you, is, Hugo, that agents and LLMs in modern terminology are being used interchangeably. So in my world, agents are not LLMs. Agents are essentially smart automated workflows where the intelligence kernel is the gravitational center. The intelligence kernel is what defines how information flows in and out of an agent and what gets called next. Of course, it can be an LLM, the intelligence kernel, but sometimes it'll be a physics simulation model for a battery performance, or it could just plainly be a set of statistical algorithms that work together. And then another agent is more a knowledge retriever from a RAG, and then another agent is something else, and they work together in a boundary condition manner. So for us, agents are not just LLMs. Agents are more automated, intelligent workflows, almost a business process that is
Mm.
mapped from your business process map into a logical pipeline.
If I simplify it, do I understand the difference correctly in saying that the agent is the one that's going to make a decision about what to do next versus the LLM, which is just like producing content?
Yes, and actually, it's not just the agent. The agent will present options to a expert on what to do next. And as the expert chooses more and more of the same output from the agents get better at proposing the right option. And then at some point, the operator can choose to just go into agent mode, where based on what the operator does next, and if there is a possibility to automate that, the operator can, just verify the work and go forward and watch and keep on verifying what the agents do. So we don't want to go and say, yeah, we are building the operating system for autonomous factories where there are no operators. I don't think that's the right way to think about it. This is more about, can we use the operator's time, and which is, money for the factory, to look and solve problems that help close the last 2-3% gap, and let the agents take care of the repeatable work. Let the agents take care of the work that eats time for operators. When they have to call one person, then that person has to call another person to get the information.
And so that's always like a human in the loop process. Like you're not
Always,
forgetting about the human.
always, always.
Look, one of the questions I had for you, and sorry to push you into that corner, maybe you had these questions as I was on time, but when I think about Aris Machina, I'm like, how does that company doesn't become a consulting company? Because to implement the product, like how do you implement the product without having to spend thousands and thousands of hours of people trying to connect and map the data and understand how the processes work and blah, blah, blah. Like, how do you do that?
Yeah, so I mean, this is a question that also keeps me up at night constantly. And if anyone, if you ask this question to anyone who's in manufacturing and they have a crisp answer to it, I would say raise your eyebrows. Because I just don't know what is the right answer, or what is, until you've done hundreds of implementations. So maybe, Alex Karp at Palantir probably knows this, but I bet a lot of their business depends on making money off of deployments, which makes sense, right? So my answer to this is, we've tried to hypothesize on what takes the longest amount of time in a deployment. And it's usually going from machine to something that is usable, queryable, and so on. So the way we have built our tools is, I call this the forward deployed agents. So we've built a couple of tools that a deployment engineer, a human engineer, can take with them and be agnostic to the landscape they are playing in, right? And the agents can help them, almost like a cursor and a anti-gravity, which we built, not those exact products, but we've kind of built a few agentic workflows that can help the deployment engineer really bring together the data up to 80% of readiness. And then you can iterate with the agent to improve that knowledge graph, right? And then the way the knowledge graph is fit with the application is very much hand in glove, right? So as the knowledge graph gets better, the application gets better. The second part of the answer is we didn't know how much time it would take to deploy these things. So we said, okay, what if we actually have a factory? So what is the best way to have like a factory without having a factory? And that's, obviously some sort of a simulation. We said, simulation is estimated. We really want real data. So when we started the company, we went and bought a data set from a bankruptcy estate, which we share this openly now with from Northvolt. So we bought a large manufacturing data set for over 3 years. So I can have the what is that Tom Cruise movie? You can play the same day again and again, right?
Yeah.
So we try to do a few scenarios of that. As we talk, the team is developing 6 or 7 benchmark scenarios that are production scenarios from a machine that failed, then came back up, and we try to backtest this, right? So it's almost like backtesting in a financial market where you know what the outcome was, but you can test your algorithms on that or on autonomous driving. Because I come from that world of data and AI where you can backtest things, right? So we said, what would be the best way to do this in a factory? Because there's no other way, really. You have to rely on your customers, and that is not going to scale. So we have to start with something that can reasonably represent all different types of manufacturing processes. Battery factories are great because it's like 3 or 4 factories in one. And then we go from there on where can we take the product, how do we tune the product for the customer. So those are a couple of things, the agentic toolkit, as well as starting the agents with a real data set. And I want to open source this too. I want to curate 5 or 6 or maybe 100 scenarios, and I want to open source it to a community who can build with us, who can actually solve these problems, almost like, the X prize for manufacturing is, can you predict, this problem from telemetry and so on.
Do I understand correctly that within your model, you will still have to have forward deploy engineers or consultants, whatever you want to call them, but like people that actually help for the last 20% of the
Yes.
deployment?
Yes. And just to last point, Hugo, if we have a software that can help take away the customization component, right? That can abstract how the data is assembled at the customer site and just handle it to an abstraction layer like a knowledge graph. Then we can even scale that to existing system integrators, right? I want to ship our product with a machine. So if a machine builder is hearing your podcast, we believe the Gemba product can easily be the assistant that goes with the machine to every customer. And the customer can just ask the assistant, how do I connect this machine to my MES, or which PLC tag corresponds to this valve or this vacuum motor or vacuum valve or whatever it may be. And this becomes even a FDE for the machine builder when they're deploying their machines and doing FATs and SATs.
Talking about your products, it's quite interesting because you've launched with 2 products, not one. I think that's quite unique. Most startups start with one, you started with two. Um, Something else that I find interesting is that these products sit at different layers. One more on the R&D side, one more on the floor or like the actual factory. What was part of your decision to launch these 2 products at the same time?
That lies in the vision of the company, which is it's an operating system for manufacturing. So if you boil this into a simplistic way, an OS needs to ship with a few apps that a company can use. So we ship with 2 apps, okay? And both the apps are leaning to physical products, building physical products. So in this case, the R&D product is more like, the cursor for cell design. So you can do battery cell design in Protos. You can start with as simple as a prompt and choose a chemistry and form factor, and it'll run simulations and agents in tandem with the expert to get you all the way to a point where you can export the cell design and run physical cell manufacturing or testing and validation. You can bring the validation data back. So you see the loop of product development, right? That's an app. So for us in the world of industries, there are kind of 3 big workspaces. There's an R&D workspace, there's an industrialization workspace, and a manufacturing workspace. We've kind of shipped apps or workspaces for those the two corners. The middle gets joined as we go over time, and I'm sure you'll see more from us in the coming year on the industrialization concept, which is more like connecting and taking a package from R&D and putting it in manufacturing. So we go after this from a true operating system sense. You'll also see a developer kit from us in the future, and you may also see something where people can test their apps that they build using the developer kit in the three workspaces. So it is a long-term vision. It's going to take time, but the first goal for us is to help people in this world, which is in the battery cell design, and it's a very complex product. And then the manufacturing product is more agnostic to industry. But if we were to pick energy, which seems to be right now one of the most crucial industries, then both these products hopefully help catapult or launch more battery companies or more people to take the risk to simplify the reasons that they fail because of. So this is the thinking that it's an app store where we have two apps and the operating system is more the crux of the product.
So would you say that in the future, people in manufacturing and industry will spend a lot of time on your app? So like they would want to spend majority of their day just playing around with different apps.
Absolutely. I think even before people build factories, I envision that they will be able to trial our product because they'll be able to also test or test machines in the product itself and test agents when the machines fail. So I see a lot more of one thing that comes to mind is what does a manufacturing world model look like? So we're talking about world models a lot in the space of AI and world model of games and autonomous driving. I think there is an interesting space on manufacturing world models. And one area that we can unlock with our data set is also building a manufacturing world model eventually, which powers some of these apps together. So, I mean, we've thought through some of this. Now it's more about breaking it down into small milestones and shipping. And the first two milestones and apps is getting traction on these two products.
Within industry, one of the things that's very complex is to go from pilots to actual revenue, or from
Yes.
pilots to actually scalable products. What sort of strategy are you applying today that you would maybe recommend to other founders to go from pilots to actual revenue?
I'm not an expert founder, first of all. This is my first company. I think what matters is we need to keep it very simple, is solve a real problem for your customer, right? So don't be afraid to pivot if more than few customers kind of have the same problem and ask you for it. And I think some of the product vision that we have uh, crafted here are a function of what we heard from our customers and what we learned ourselves as well. So listen to your customers is my only big feedback to go from pilots to revenue. And sometimes you will have customers who will look at your team and look at your composition and go like, yeah, but maybe you can do this one project for us. And then it comes down to just very cleverly mapping capacity to what you really want to do versus getting a wedge in the door and proving yourself. Sometimes you may have to do that for big customers to prove yourself. To your earlier point, becoming a consultant company, you just have to be very aware of not becoming that, but being very clear with your customer and asking them, what is the core problem that you have that I can solve? So in our case, we did a whole bunch of work asking customers initially, and a lot of customers told us, no, do this project for us. And we even kind of leaned there if we could get to something interesting. And oftentimes the customers appreciate that and they say, okay, well, we don't think this is your core competence, but you built something cool. Show us that. How can that help me? And sometimes even that patience pays out. So I think, the future is going to belong to the patient in this space. And I say the same thing to investors and same thing to founders. You can execute and iterate with speed at no exceptions. So I'm not saying go slower. I think, but the resilience and patience needs to be paid out, and founders need to be patient, and investors need to be patient.
Talking about investors, we'll have to be quick on this one because I have to let you go afterwards. But how do we pull off roughly $10 million pre-seed? I mean, that's unheard of in Europe.
Yeah, it's a good question. I think I will just repeat what the founders or what the investors have said. Um, I think so let me say, I heard about 300 people say no to me between January and April. So it was not like we showed up in the arena and we did a knockout game in the first round, right? It was not that. We had a lot of doubts. We had a lot of conversations. We doubted ourselves multiple times whether this is even a good idea. Is it too big? A lot of my investors said, "Well, we'll wait on the sidelines till you show us a proof." And I was like, "Okay, this makes no sense. If I could prove, then why would I need your money?" Then so but kudos to Early Bird. I knew Planet A, SNA, Village Global, all these folks. They really leaned in. I think, Early Bird really did an incredible job at doing the background check. Paul, Moitz, Ferdy there. They really helped us even hone the vision further and think through the problem. And same credit goes to Nick and Fabi and Max at I know at Village Global and Snow. We were not looking for a big set of investors, or we were primarily focused on what do we need to get to the next milestone. But as we started laying out the vision, and I said I want a data set, and that will burn some money immediately. I want to hire this team that's available to me. I think we can get to market. It's a big vision, but maybe we can deliver 2 products in the first go, or maybe 3. We don't know. And then the vision evolved. So I think the investors saw something that these guys are onto something interesting and could be big. So we should take away the challenge of raising money and distracting them again, because there needs to be patience, as you can imagine. So they gave us some, what I like to call, patience capital, that we can last out more than 12 months in a pre-seed, pre-product stage. So I think that's where the pulling this off comes from. It was both a conviction building exercise on the investor side, and of course some storytelling. And you can see our content, and we'll be putting out a whole bunch of blog posts soon on how we approached this vision and what were the early days of discussing this look like.
Yeah, for sure. And I'll definitely refer people to your lunch video. Amazing work. I don't know who did that, but
I
so
can tell
cool.
you who
Like,
did that. His name is William Steele. He has a company called Corinthian, and we are friends and colleagues from Northvolt, and he did a lot of the work at comms at Northvolt, and I want to give him a shout out that he developed the launch video, the brand playbook, with a couple of other of his colleagues. So yeah, and then we did a lot of the scripting along with him, Peter and I. We had a vision in mind on what story we want to tell, and the logo, of course, is as you can tell, is the ASCII. It's the ASCII code for the name of the company. I want to do a shout out on that. We went back and forth a lot on the name, but then on the logo, we even went more back and forth. And it was more about being eternal. So binary code is the last language that humans will ever invent, hopefully. Now it's going to be all about embeddings. But if you boil down embeddings, they're also binary code, right? So we wanted the name of the company and the logo to kind of be eternal on machines that will build the future. So our dream is to put the logo of the company that is actually readable by AI. If you point ChatGPT at the logo, it'll tell you what it means. It just figures out that it looks like ASCII code for the name Aris Machina.
look, fire questions. You have 1 sentence maximum to answer for each of
Yeah,
these questions because
let's
we don't
go.
have time anymore. What's one belief you hold about manufacturing that almost no one else agrees with?
That's a very Peter Thiel question. Factories will be much, much smaller in footprint.
Super interesting. Do you believe in the autonomous factory?
I do. Absolutely.
Is that a 5 years or 100 years place? Like, what do you place the
That's
autonomous
hard.
factory?
I mean, I could argue, there are autonomous factories already in play. Like a 3D printer is pretty much an autonomous factory. It just depends on what you think of a factory. So that's why the footprint and the autonomy is almost hand in hand, right?
Yes.
Yeah.
What's your reaction to the argument that, Chinese battery manufacturing already runs at, near zero defect rate and that Aris Machina is somehow, late to this party?
Yeah, I don't know of many companies in China that are doing exactly the same things we're doing. But I think the tip of the hat to the Chinese, they have been resilient, very hardworking, and they've designed incredible ecosystems for battery manufacturing and supply chain. So there's a huge advantage in owning the supply chain, which is, Chinese are already there and they're flexing it. So I don't think it's fair to compare ourselves to the Chinese ecosystem. That's like, the David and Goliath difference. We are we are definitely the small fish here. But there's a lot to learn from how they have scaled things. I think Europe can learn, US can learn. But I don't see this as a competition. I think it's more about what can we learn, what can we do together, and what can we do well here in Europe.
I love that. And then one last question for you. Where do we see you 10 years from now, 15 years from now? What's the vision?
I mean, I gave you the vision. Is I would like to have the RS operating system powering every new factory. There, thousands of developers developing manufacturing apps and a new economy around manufacturing apps powered by AI rising. More young entrepreneurs designing and building new types of products at lower cost. New materials being invented on the RS platform. So yeah, I mean, we are in this for the long haul, and we start with a couple of products, and I hope the market welcomes us and gives us a chance.
And well, best of luck for all the work ahead. Congratulations again for this massive first round and release of the brand and the products. Thank you so much for stopping by. I know you have to go, so feel free to drop, but it was a pleasure and an honor to have you on the podcast. Thank you so much, Sid.
Thank you, Hugo. This was really nice, and congrats to you on this amazing podcast. And looking forward to come back again soon.
Sounds good. Well, you have my number.